Ahoy, Captain, and welcome to this episode of First Aid for a Sustainable Ship, a series in which we provide guidance on decarbonizing your vessel. And in this episode, we're going to take a ro-ro passenger vessel, as you can see here, quite a big one, 33.6 megawatts installed, operating in northwestern Europe, and we're going to apply Ecospeed coating to it. And Ecospeed is not just a coating as such, everything coating applied to the hull. It's actually a coating system, that's how you should see it, because it also includes regular cleaning of your hull in order to reduce fuel consumption and reduce emissions. So more on that later. First, a short summary of what you can achieve with applying Ecospeed to your vessel or a ro-ro passenger vessel. We're going to call this case study the Lady Ice Cold, and there's a reason for it. You'll hear it later on. We see between 7 and 23% CO2 emission reduction, and it has to do with the fact that over the years you will actually achieve more carbon emission reductions or fuel consumption reductions because of this coating system that we'll discuss probably in the second part, because then we have some nice pictures and graphs to show it for. Capex itself is, for this case, we're looking about, well, roughly $500,000. It's actually pretty close to the capex of applying regular coating. Price difference is, from what I can say, between 20-25% max. Some cases maybe even in the same range. So in a sense you can also, well, we're gonna take this capex and see how it will affect your business model later on, but suffice to say it's in the roughly the same range as a regular coating, but we do have the OPEX component of cleaning, so that's not regarded or reflected in the capex. It will give you a payback of pretty fast, I'd say. Payback of about 6 months minimum. It depends a bit on how we calculate the carbon emission reduction. It can be a little bit more in the first year, but it also depends on your current hull status. If your hull is already in need of repair, then or maintenance, then actually payback could be faster. And I wanted to state that even though we have made this together with Subsea Industries, the makers of Ecospeed, and also the writers of this book, actually it's Bout van Rompuy, who's the CEO who wrote this book. I have most of my information from this source. We don't receive any money from them for making this. We're just, I'd say, big fans of what they're trying to achieve, which is a marine ecology with less toxins from regular toxic hull coating. So actually what Bout would try to achieve a few years ago, quite some time ago, as a diver, he saw the impact of anti-fouling systems on the environment, and he thought he could do better. And actually the carbon reductions are more or less a side effect, a very positive side effect of this hull coating system. So I'm quite enamored with their vision and their goal and what they're trying to achieve, and you can say that's why I'm a fan, and I think this could be a very good product for specific vessel types, including the Lady Ice Cold. So let's dive in, first by saying there are two parts to this episode. First part is the online tool in which we'll provide assumptions and show you the vessel. Second part is the premium reporting part, for which you normally pay but you get for free in this episode. So the input and assumptions will show you more or less the sensitivity. We'll also discuss some sensitivities in the premium reporting that you do not have in the freemium online tool. And then we'll go into discussion mostly about the technology itself. Before we dive into the matter, however, a short disclaimer. The Decarbonizer is a model. It is a model to make long-term decision making with regards to sustainability, but we just wanted to state that while the model itself is of course not a reflection of reality. We make assumptions. Sometimes those assumptions are in a good range, sometimes they're not so much. So understand the sensitivities of the model. That's what we're trying to say. Secondly, it's constantly evolving. The version that you will see here will probably or most likely be different than the version that's now online. So evolving doesn't mean it's worse, it's usually for the better, but bear in mind that these small changes will reflect the layout and the outcome that you see here. It's also made by, as you can see here, a human, and we make small mistakes. So if you find errors, please let us know. That's feedback that we value very much, but bear with us as we are constantly evolving this model in order to make it better. And those small errors, well, unfortunately will be part of the process, but in the long term or the long run, we hope that it will only make it better. And finally, again, we are independent. We haven't received any funds or money. We just do this because we want to make the world a better place. And we still need to make some money, of course. That's what we're trying to do by helping you with premium reporting. But independent from suppliers means that we get this book, this one, as a source, and we also show you where we get all the other types of information from. We are open and honest, and we try to make an independent, objective view on your vessel in order to help you sustainalize your vessel. That's it for the disclaimers. Now let's go to the first part, the online tool part. Let's click here. And here we have our vessel, Lady Ice Cold. Well, actually, if you click on the link that you just saw, then you will see that Ro-Ro Passenger might not be the first vessel with this amount of power. We've already pre-inputted some things in this tool to make life easier. Here you see that all the different ship types are included. These are different ship types according to IMO, EXIE, the INCI standards, plus some additional ship types, including offshore, dredging, blah blah blah. These are not important for the moment. This is the total installed power. Most of the information regarding emissions is due to, of course, your fuel combustion and installed power. Once you have inputted your preferred vessel type and your total installed power, we can click on the button Decarbonize your vessel. There we go. We already have hull coating Ecospeed applied here, and this is actually the most important. This is one of the most important tables that we use in order to get a good objective overview of all the different measures that you can apply to your vessel. Let's see what we have. So we have shore power, prevent measures and change measures. Well, shore power is the use of electric power onshore. Prevent measures are those that reduce fuel consumption or prevent the combusting of fuel. And then change measures are everything else, mostly changing your fuel mix. And then we have our little table over here with the different measures, the carbon reduction, the costs, capex cost, delta OPEX, that's the difference in OPEX. So everything that's negative will actually reduce your daily OPEX. And here we see roughly 3,000 euros reduced in OPEX, which gives us almost half a year payback time with this kind of capex. So for this case study, we'll only apply a hull coating, that's it. But what we can do is maybe show you some of these sensitivities in this case study. Probably not the capex though, that will do the second part, premium part, that cannot be changed here. But if you see here, most of this business case is of course dependent on the fuel price. As you can see, well, even if you have a very low fuel price, as you can see, I haven't really noticed that. Even with a very low fuel price, you'll probably see payback times that are very close to 1 year. So even in your first year, you'll probably see some payback. And that has to do with the fact that actually fuel consumption reductions are quite high for this technology. As long as you do regular cleaning, then you should see up to, well, according to the surface treated white composite or surface treated composites white book, in the Second World War, the Americans or the Allied Navy saw up to 40% reduction in fuel consumption or 40% reduction in fuel consumption when they had a very clean hull or just clean hull, or 1 or 2 knots extra speed, which is actually one of the reasons why a lot of navies at the moment are applying these kinds of coatings, because the speed increase, you can either have a speed increase or you can have a fuel consumption reduction. You need less power in order to achieve the same speeds. So that's why this could be a very useful technology, but the cleaning part, we'll get to it later. First, something about the ship. This is very important, of course. This is our representative power demand. This is actually a graph that shows the way the vessel operates each year, and this is a very hypothetical graph. Here you see that some of the time we are simply idling or moored. This is actually not a lot. The vessel itself is operating quite a lot in this case. So this is the sailing part. So about, let's see, sailing, 38% of the time we are sailing and 38% of the time we are working. We have idle moored, sailing, and working is everything else. In this case, the Lady Ice Cold is either operating in a harbor or just waiting alongside the quayside in order for people to get on and off. So with some peaks when she is using thrusters or whatever. To be honest, this is, in this case, I know for a fact that this is incorrect, but this is a conservative scenario because the Ecospeed hull coating will only achieve fuel consumption reduction when it's sailing. So actually in the idle moored and in the working cases, we do not have any savings whatsoever. So only for that 38% of the time that you are sailing, we see reduction. So in case you are sailing 50% of the time or more, your fuel consumption reduction and your payback time your fuel consumption reduction will increase and your payback time will decrease. You will actually see more benefits from the technology itself. And here we have, for the Lady Ice Cold, we have about 55,000 liters or 55 cubic meters of fuel consumption per day. So we have about 55 cubic meters of fuel consumption per day. If we look at the OPEX breakdown, we see the daily and the yearly OPEX. This is for the 3 different operational profiles, and this we use if we are sitting down with you in order to see, okay, for each profile, does that concur roughly with your current fuel consumption, etc. at that different profile, because then we can state with more certainty that the profiles that we have here more or less are similar to what you have in reality. So what else is important in this case? Ship and fuel parameters. Here you see some of the parameters that we have used for this vessel with some of the operating speeds, etc. The list in the back end that we'll see is quite a lot longer actually than this one. The operational profile, if we want, we can also change the operational profile. So let's see if we have more idling, more days. In this case, that will of course reduce the amount of working days, and maybe, so we had about 7% fuel reduction potential. What if we have a lot more sailing days each year? Go back to CO2 reduction, standard table. Yeah, we see that our CO2 average reduction will be 11%, so from 7 to 11%, but that's the 10-year average. We'll see later on how that goes over the years, but well, that's almost 50% on top of what we had previously. So as you can see here, the operational profile has a lot of impact on your fuel consumption reduction and also thus your emission reduction. Finally, engine characteristics. This is usually for us the most tricky part because we assume quite well, they're based on quite a lot of theory, but I know for a fact the theory doesn't always concur with reality. So these fuel consumption curves for engines are, well, in this case, as you can see, quite low. This is a medium 2-stroke engine HFO, so the fuel consumption will be roughly about 150 grams per kilowatt hour if she's running smoothly. This is really something that we need to check together with you when we are doing this exercise together. So you see, for this engine, it's quite a, well, you could say efficient engine, because we have quite a low specific fuel consumption. What does that mean for your business case? This is a conservative estimate. If your fuel consumption curve is higher, or your specific fuel consumption is higher, which, well, for a lot of engines is about 180 grams per kilowatt hour, then actually what will happen if we change it, then your fuel consumptions will of course only increase. Here we go, 170, 80, well, roughly. And that means we will get more money from, we will see a higher payback rate from our savings. Of course, that's easy. Okay, so this is about the technologies, etc. Then we have some rules and regulations, because, well, why would you want to do this apart from making some bucks in the process? Well, 11% is actually the 2026 goal for IMO in terms of carbon emission reductions that we see here. So IMO carbon intensity in 2026 is 11% reduction. And that means that with this technology, you'll probably comply with those regulations. All the way up to 2030, I'm not so sure. Probably by then you have to add more technologies to your mix. But suffice it to say that at least in the coming, 2023, let's say at least in the coming 5 years, you probably comply with rules and regulations. And if your vessel, if your Lady Ice Cold will sail after 2030, well, then we have to think of more measures or different measures with respect to. Now we simply have to think of more measures in order to comply with that regulation. But we can use the rules and regulations, decarbonization timelines in order, and also other rules and regulations in order to see with which rules and regulations we need to comply with. So this tab gives you more of an understanding in the amount of emission reduction you need to achieve in order to comply with the rules and regulations either in your area, or if you want, you can also include energy majors that are maybe your clients, etc. So that's it mostly in terms of inputting and sensitivity. As you can see, not everything here can be changed and adjusted, but that we will do in the second part. So normally you can get your Decarbonizer report here. So you can simply enter your email and we will send you a report with the information that you have inputted. So let's go back to the second part and see how that looks like. Onwards and upwards to part 2, the premium reporting part. If you click on the link here and skip verification, and then you will see the page that we have set up all your information for further reading. So here we have what we just now discussed, and if you scroll down you see the Decarbonizer itself, so you can customize your own example. We're going to go to the download report part here. There we go, nicely set up for a 2-page view. And this is usually the part where we go in depth on the technology together with you. Most of the things that we see in this report we have already discussed, but we brought a book for more information and further reading, a coffee, and we'll go in detail on the technology and Ecospeed itself and why it actually causes the fuel consumption reduction. So here we see the executive summary and what we just now discussed. And if you see here the CII and EEXI, they are not good. They're actually above what is required. So in this case, 4 times D in a row, and a EEXI that is higher than your required EEXI will lead to difficulty with class. So you need to lower your fuel consumption anyway, but again, this is all based on this operational profile. Well, actually, the CEI is based on this operational profile. EEXI is based simply on continuous sailing mode, pending your vessel parameters. So for CEI, you might be able to change your operational profile. For EEXI, you need to do some other. Well, we decided to do to apply Ecospeed as a hull coating with an average. This is a 10-year average, and I'm going to go in detail later, of 7% CO2 reduction and thus fuel annually, which leaves us with a roughly €3,000 delta OPEX, which is the difference in OPEX or your day rate difference. So negative is actually good, because then we have a lower OPEX, as you can see here, with quite a fast payback rate, around roughly half a year. And that all depends on how you measure it, of course, and I'm going to show you the calculation. So moving on, the report itself, if you have a look, encloses everything that we have discussed plus more. Here we see the operational profile, we see the key upcoming rules and regulations in a little more detail, and then we have all the carbon reduction measures and the costs involved that you have. Plus, of course, some appendices that we're not going to discuss this time in detail, but that's more for reference purposes. We've discussed the disclaimers. Here we have the input parameters of the vessel that we used for further reference, OPEX profile of the different operational modes, and the average. Well, this is sort of an average day, but I mean, what's an average day for a vessel? Every day is unique, every vessel is unique, but this is used for calculating purposes and to actually compare different vessels and working modes. And here you see in more detail the combined yearly average and also different operational profiles per day, with also an estimate on engine settings. And as you can see, for sailing usually we assume between 70 and 80% depending on your vessel, and also depends on what's stipulated by EEXI. And in working mode and idling and moored mode, we usually see low engine load setting, usually between 50% even. 40% can be quite high, depends use your vessel. Key rules and regulation for reference, and here we go. This is the fun part. We only apply hull coating in this case, as you can see, and immediately our CAI and our EEXI are reduced efficiently enough in order to comply. And we're gonna skip shore power because we don't have it. Here we have more details on Ecospeed. So this is a lot of information. We'll go, you don't have to read this part because that's what I'm gonna say to you. We have the details used, or the input parameters used for calculations, and on the right hand part we have a direct copy of some pictures from the Ecospeed leaflet. These are also in the link that you can download, and maybe we can start with those before we enter the calculation, so you have more specific insights in what Ecospeed is and what it does for you. So Ecospeed is actually usually 2 layers of hull coating. That's glass pellets based. So so normally when you apply it, you grind all the way down to bare steel. You apply 2 layers, and Ecospeed itself has glass platelets. I thought it said pellets, but it's platelets that ensure that any corrosion or abrasion is resisted. But that's also why you need to keep it clean, because then you can still have marine life attaching to it. And as you can see here, this is where the cleaning comes in. So when your vessel is in port, you can clean all the different parts of the vessel. And these examples are actually quite commonplace in the leaflet itself, but also there are some use cases here. My favorite one is the Ernest Shackleton. That's an ice class vessel. There we go, sailing in Antarctic ice. That's the one. Yeah, so why does it work well for Arctic vessels or ice breakers? That's because they are usually surrounded by ice, and the ice automatically cleans the vessel, so you don't have to go import to clean. So that's why Ecospeed is a hull coating system, because you need to apply the coating and you need to keep your vessel clean. Commonly once every 2 months is advised. That's why we have Lady Ice Cold. She also sails in icy waters, but also for a ro-ro, each time you moor at your moored location in one of usually either 2 ports or well, at least the ports are usually known. You know where you can clean your vessel, so you can set up the system itself. Back to the calculations itself. So how do we actually get CO2 or a fuel consumption reduction? That's because of 2 things. It's hull roughness reduction. This is a regular hull after a few years of working at sea. So you see that the hull becomes very rough, even with pits and abrasions in it. And also because of the cleaning itself, you stop the marine life growth. So that's common marine growth on steel plates in water. So Ecospeed is very abrasive resistant, so your hull roughness is very smooth for your entire vessel, which reduces drag, and also because of the cleaning you reduce your fuel consumption. That's nothing new. The US and the British Navy, they already knew that in the Second World War. Great stories about that also in this book, actually great reading. Great reading material. But keeping your vessel clean and also keeping your hull smooth will actually reduce fuel consumption. So how do we calculate this? And also the cost will come later, but I'm going to go from top to bottom. It only works when you are sailing, of course. So it applies to a certain ship hull area. That's for our pricing. So here we calculate all pricing compared to conventional coating cost, and I'm actually going to show you using the back end that even if you have free coating, you will still save a lot of money using this system, only if you can have regular cleaning, of course, provided you have regular cleaning. That's important. But even then, the fuel savings are way more than the actual cost of applying Ecospeed. 6 times cleaning per year. We have cleaning costs also assumed there, and the hull roughness. That's also very important, because if your hull roughness is already smooth, then you will actually have less reduction. So this is a conservative case. Ship age, that also has to do with the smoothness. And then here we see fuel reduction average. In this case we have 13%, but it's a minimum and a maximum, and I'm going to show you in the back end how we calculate things. Current hull coating cost compared to Ecospeed hull coating cost. This is purely the coating costs with cleaning, and as you see that at first glance Ecospeed is about 200 euros or more expensive per day. The fuel reduction itself, 2,238 per day, is way more compared to what we have with Ecospeed. And of course you also have other benefits such as the reduction EU ETS. But the percentage cleaning cost is a very large part of your daily operational expenditure, so that absolutely has to be taken into account. And here we see conventional coating, grid blasting, true. That means that we are now comparing the case where we have to apply, well, we have to grid blast every 10 years and apply new coating after 5 years. But even if you get that for free, you're still, it's still gonna save you money. Let me show you how exactly. So here we have the back end of the report that you just saw. It's all the same, but this is where we do our magic, so to speak. And this is also where we can change all the different parameters in even more detail. So let's see. I'm gonna first show cost, because the cost, as you can see in the top right bottom, actually reflect how you save money. So a large part of the cost is simply procurement of the coating itself, and of course execution retrofitting. That means applying the hull coating. We have a breakdown here, but I'm gonna zoom into fuel consumption and reduction versus age of ship. So what actually happens is that over time your fuel consumption increases in our modeling, and also Ecospeed's modeling, because your hull roughness is actually kept the same, so you still have a smooth hull. You see that it can actually accumulate a lot, up to 40% in certain cases, as discussed by the navies in the Second World War. That's also one of the reasons why navies in particular are very fond of this technology, is because you can either use it to achieve fuel reduction, or you can use it to achieve higher speeds or maintaining the same speeds at a similar load. So that's it for our reporting. And if we're gonna close this one down, and then we see the rest of the report. And in the rest of the report we see, of course, capex breakdown. In this particular example, only in the back end we have the reduction over time included. So as you can see in the premium version that you purchase, we can actually go more in depth into the calculation. We can actually put them in the report, answer more of your questions, etc. So that's that detailed explanation is of course what you pay for. Finally, we can provide you with the suppliers, our preferred partners, but also potentially others. You get a OPEX breakdown, so you see exactly how the cost savings are included, and if we play around with the parameters, you actually get insights into so in that case, even with free coating, we can still make money. So let me show you how that works. So here we have the calculations that we use together with taking there fuel consumption reduction versus age of ship. But we're interested to see what if we have conventional coating cost for free, application and grid blasting cost 0. We're gonna zero the conventional coating cost. We still have cleaning and still have Ecospeed hull coating cost. Let's see what it does to our 10-year average. Here we go. We still have grid coating cost when applying, so we're gonna make that 0. There we go, so you don't have those expenses. And then here we see that we have a lot of cost incurred for the coating. Ecospeed coating, regular coating is 0. So then we see that, okay, compared to our first year and 6th year when we have to do a lot of investment. But here, what we see here is that we still assumed that in this case 0 to 5, then year 6, we still are at year 0 in terms of hull roughness. Conservative estimate, if we're actually being honest, we have continued that onwards, so that our fuel reduction is actually increased over time. And this would be then the profile, but let's see if we can. This is even more conservative. So let's see what the cost reductions are in that case. We still are left left with, see, Ecospeed fuel cost savings. Yeah, there we go. 16 million over a total of 10 years. And let's see what it does to our daily average. Still 7%. So that, yeah, even with free coating and non-conservative or a very conservative estimate of your savings, we are close to what we started with. So we started with 3,000 euros per day less. Now we are at 2,700. That's 2,500 if you want to be even more conservative. So actually the costs of the coating itself are a lot less compared to what you can save in terms of fuel consumption. So that's how we calculate things. And again, if we go in detail in these calculations, we can assume your assumptions. We can change the input parameters to your liking, and then you get what you always wanted. You get insights into long-term decision making on sustainability for your vessel. And that concludes our first aid for a sustainable ship regarding Ecospeed hull coating system for the Lady Ice Cold. We saw a fuel and emission reduction in the order of, well, let's say 10 to 20% easily, depending on the time of the lifetime of the vessel when you apply the coating with respect to regular coating. And we saw that most of your gains are actually in the realm of fuel consumption reduction, but we need to make sure that we are cleaning at least once every 2 months. Depends on where we sail. If we have more icebergs, then that can keep our hull clean, but generally we have to consider Ecospeed a hull coating system that does not apply to all vessel types. But if it applies, we saw great emission reduction and also no toxicity for marine life. If you have any more questions, feel free to contact the help desk, and if not, have a great day.